Congruence between triangles. Proof using SAA Congruence Theorem. Example, this is the figure. Given segment AB is congruent to segment CD. Segment AB is perpendicular to segment BC, and segment CD is perpendicular to segment DA. We are asked to prove that triangle ABE is congruent to triangle CDE. We are going to prove this using a two-column proof. In the first column, we are going to write the statements, and in the second column, the corresponding reasons. For our first statement, segment AB is congruent to segment CD. Let us indicate this in the figure. So the reason is given. This is the S or side. Segment AB is perpendicular to segment BC. Let us indicate this in the figure. And segment CD is perpendicular to segment DA. Let us indicate this in the figure. The reason is still given. In the figure, it says here that this is the perpendicular. The segment AB is perpendicular to segment BC. Yeah. Therefore, this is a right angle. And then this segment CD is perpendicular to segment DA. So this is also a right angle. So for our next statement, angle B and angle D are right angles. The reason, definition of perpendicular. According to the definition of perpendicular, a line is perpendicular to another line if it crosses it at right angles. Angle B is a right angle, and angle D is also a right angle. Therefore, we can say that they are congruent. So for statement number 3, we have angle B is congruent to angle D. The reason, any two right angles are congruent. So we have A for angle. Let us look at the figure. We can see that angle AEB and angle CED are vertical angles, and we know that vertical angles are congruent. So for statement number 4, we have angle AEB is congruent to angle CED. Let us indicate this in the figure. Okay. The reason, vertical angles are congruent. So we have another A. For statement number 5, and this is our last statement, we can now say that triangle ABE is congruent to triangle CDE. The reason, SAA Congruence Theorem. According to this theorem, if the two angles and the non-included side of one triangle are congruent to the corresponding parts of another triangle respectively, then the triangles are congruent.